In this example, we're given the following question to solve. XOK is the angle theta, and it is in the third quadrant. K is the point -5 and Y. OK is 13 units. Determine without using a calculator. So step 1 is always that we need to plot our point, which in this case is K, on our Cartesian plane. So in this example, we're given a little bit less information, so it makes it slightly harder. But if we just follow this systematically, it's actually pretty simple to solve. So we're told that point K is at the xy coordinates -5 and y. So we are not given a value for y. And we are told that this is in the third quadrant. So x minus 5, let's assume that's somewhere around here. Y we need to find. So let's say that y is this point here. Then where those 2 points intersect, we can call that point K. So that's at the xy coordinates -5 and y. We'll then join that line to our origin O. And then we are then told that the angle theta is XOK. So x from our positive x-axis round to our line OK is then the angle theta. We are then told that the length of the line OK is then 13 units. Okay, so the next step that I always follow is to write down the SOHCAHTOA mnemonic. So SOHCAHTOA. Alright, and then we just fill in the substitute sides x and y and r for our adjacent, opposite, and hypotenuse respectively. So in the case of the sine function, our opposite side is y and our hypotenuse is r. In the cosine function, our adjacent side is x, the hypotenuse is r, and then our opposite side over our adjacent would then be y over x. Alright, so that just makes it easier for me in terms of the Cartesian plane, because I can never remember these trig ratios off by heart. Then the next step would be to determine the value for y. So we'll then use our theorem of Pythagoras to determine the side y. So we know that the theorem of Pythagoras says that the hypotenuse squared is equals to the sum of the adjacent squared plus the opposite squared. So we know that we need to solve for y. So we need y alone on one side of the equation. So y squared is equals to r squared minus x squared. R we know is the radius of the circle. So that would then be the line OK. So that's 13 squared minus x. That is a value that we have been given. So that's -5 squared. That's then 169 minus 25. So that is then 144. So to get, that is then of course the value of y squared. So therefore we can say that y is equal to plus or minus 12. Right, now plus or minus because x was a negative value. So let's see, is this a plus or a minus 12? We know that this is in our third quadrant. And we know that in our third quadrant, which is down the bottom here, y is a negative value. So we then know that y is minus 12. Alright, so now we have solved all our variables in this sample question. So then it's pretty simple then just to substitute into our equation. Alright, so what is the question then? The question is then that we need to prove that the tangent squared of theta plus 1 is equal to secant squared of theta. Alright, so let's do that. So we have the left-hand side of the equation, which asks tangent squared of theta plus 1. Alright, so we know that tangent is y over x. That's y over x squared plus 1. Y is, of course, negative 12 over x. And our x value was minus 5. That squared plus 1. That then gives us 144 over 25 plus 1. Now, in this case, we can also write 1 as 25 over 25. Right? So that we have the same denominator on both sides of the addition sign. So we can then simplify that so that we get 169 over 25. All right, then we need to solve the right-hand side of the equation. So on the right-hand side, we have secant squared of theta. So secant, we know, is the reciprocal to cosine. So cosine is the adjacent over the hypotenuse, which is x over r. So secant would then be the reciprocal to that, which would then be r over x. So r over x squared. R we determined to be the length of OK. Well, we didn't determine that. That was given to us. So that would be 13 over x, which is minus 5. So that's squared, which then gives us 169 over 25. All right, we need to fix that so that it's not 29, it's of course 25. And this then says that our left-hand side of the equation, so therefore the left-hand side is equal to the right-hand side. And we have then proven that the tangent squared theta plus 1 is equal to secant squared of theta.